Hello, everyone. Um, Hope you all are enjoying OpenSearchCon 2023. And sorry, I'm sounding a bit under weather. I had food poisoning last night, so I'm a bit weak. But yeah, hopefully, we'll try to learn some stuff about object storage and how to create, restore snapshots, and also how to tier them. And also, we'll talk about how to search these snapshots from object store and so on, right? So my name is AJ. I'm a developer evangelist, and I primarily focus on building infrastructure for startups and getting them from the bootstrap stage to setting up their infrastructure and also maintaining that afterwards, right? So that is my main background. And today, as a DevOps engineer, I wanted to talk about some of the most common tools that engineers use as they come across. So one of the things is logging, right? So logging, metrics, all those are very, very important part of tool set for any DevOps engineer. So I thought I'll talk about some of the important configurations and features available where we can integrate object storage with um, search and so on, right? So why do we want to use object storage versus a traditional store such as SAN and stuff, right? So normally when you scale as the capacity needs increase, there are most of the time it becomes cost prohibitive in a way where if the size is, let's say, a couple of gigs and even like a couple of terabytes, you might be able to get away with a traditional SAN NAS storage. But then as the data size and the capacity increases, you would need something more efficient and not be able to have additional resources on trying to scale it and capacity and so on. So you would just want to um, have the same scale and performance, but not the cost added to it, right? So the goal of this is to be able to uh, get a cost-effective storage, but at the same time, not sacrifice on performance and distribution and other abilities to sort of use to store your data, right? And all of this is achieved not exclusively via hardware, even though you need fast drives and you also need fast networking as well, but not necessarily, RAID and caching mechanisms and so on. So the goal is to just use software-based architecture to do most of the distribution and scalability, and then we will um, be able to store our data, right? So what are some of the other benefits? So generally, with the SAN and NAS, you need specialized hardware and even specialized networking equipment to get up and running. And even at that cost, sometimes you won't be able to scale or be able to build the clusters at the scale which you are normally used to. So even in today's day and age, like if you use a lot of test data or lab data, that itself is very huge, and storing that on NAS and SAN will be even more cost prohibitive. So in those cases, it makes sense to store it on commodity hardware with a bunch of drives, let's say something like JBOD, and then be able to expand that into multiple pools as well. So maybe initially you'll start off with one node, a couple of drives, and then you want to expand that into multiple pools of servers, and even not within a data center, but also geographically distributed across multiple data centers and locations, right? So it's a balance of cost, performance, scalability, and capacity. So how do we now use this to kind of for our open source cluster and backend, right? So the advantage of using object store as opposed to other traditional NAS and SAN is one thing is object storage is cloud agnostic. So if you want to get it up and running, say in AWS or private cloud or even a physical data center, you can do this without much of an overhead. So if you can run a binary in on like a operating system or in a Kubernetes or a Docker, you should be able to do that. And it doesn't even have to be physical node. Like if you want to test something on your local laptop really quick, you should be able to launch it and test it even without internet and that stuff, right? So it has to be usable in many environments, and also it has to be um, sort of um, a lot less technical debt compared to something like SAN and NAS. So that is the goal for deploying an object store instead of like a traditional backend, right? So how do we actually deploy this? I apologize, it's kind of small there, but basically we are launching a Docker container and we are setting the host port, and a couple of host volumes will get mounted onto the container. And those are the disks used by the object store. And then we have a couple of parameters launching the actual container itself. So you don't have to copy that. You can, I'll share the slides later, but essentially, depending on your node where you're launching it, it can come up within like 20 to 30 seconds. And after it comes up, you can either use a CLI or a browser to log in and do all of the operations. Um, so the first thing we'll do is create a bucket and then store that data in that. So once you launch this and go to localhost, the credentials for this is default in the docs. It's basically Minio admin. And then we'll create a test bucket to store our OpenSearch data. In this case, we'll store it in test bucket 123. And that is where we will keep all our snapshots and so on. So why do we need to register um, the object store? For a couple of reasons. So in order to perform some of the operations in OpenSearch, such as backing up indices, restoring, and searchable snapshots, and we'll go through in a detail each of these, but also index state management, which you might also think of it as lifecycle management of the data. So we'll go through how we can store this in an object store, be able to retrieve from it, and so on. So before we can even use an object storage with OpenSearch, we first have to configure it. So in order to do that, we have to set the access key and the secret key, which is the same as the login for the console. So the same we used for console here to log in, we can use the same credentials here as well. And then we'll be able to configure the the object storage credentials in OpenStore. And then we also need to set the endpoint to point to the Docker instance here. So localhost 20091, that's what will point it here. And then the protocol, in this case, I chose HTTP, but in production, I'll recommend HTTPS. But the goal is once you have the configuration set up, there's one more step. So this is where it actually registers the object storage to be able to use with OpenSearch operations. So here we use the Snapshot API endpoint, and then I name the repository object storage repository, but it can be any name. It's just arbitrary. So, but remember that name though, because we'll use that in the other calls as we go through. But when you initially configure it, it can be anything. So we select the type as S3. So this can be any S3 compatible object store. So if it can read the S3 protocol, you should be able to use it. And then the bucket name, which we created here in the step test bucket 123, and I apologize for the typo there in base path, but basically, if you have multiple applications using the same bucket, you can then have it separated in the bucket, or you can use a dedicated bucket and then you don't even need that. But essentially, you can separate out the data when you want to store it. And once it's registered, then we can do the next set of operations. So this is one of the common ones, taking a snapshot. So once the object storage is registered, it's pretty straightforward. So we use the snapshot API and we name what the repository is, in this case, object storage repository, and then the snapshot name. In this case, it's one. And you can also add a flag to this called um, wait for completion. And essentially, it will wait for the snapshot to finish and then it will return it back. But most often than not, I would probably recommend just not using that flag and just using put, because then if the snapshot is very big, you don't have to wait as long for it to finish. So you can just check the status, say if you have a cron job or some script which needs to do another operation based on the status of the snapshot, you can then query with the get, and then you can ensure that the snapshot, I believe there are a couple of stages: in progress, success, and then even failed, and maybe a couple others. So based on the state, you can then move on to the next step, right? So that's pretty straightforward. Now, I would assume if you are taking a snapshot, you would also restore it from time to time. You won't believe how many times me as a DevOps engineer, I take snapshots, but then I don't test them by restoring them. And then when I actually need it, it doesn't work. So, and it's so frustrating that you have like hundreds of snapshots, but then because you never test it, it doesn't work at the time you need it the most. So generally, I even automate the snapshot re- restore part. So what I mean by that is I'll either have a Jenkins job or some sort of a GitHub action where after the restore is taken, I'll actually launch a VM with maybe a single node open source cluster and then restore this data in there. Not only that, you can also query for some example data which you expect to be in there, and then you can validate it against example data to see if it matches. So I always recommend testing and restoring the snapshot before actually calling it, a working good snapshot, right? So, okay, fine. So you take snapshot, it's working well, fine, so on, and then you query it when you need it. But what if the snapshot is too large? So say if we have a 10 meg, 100 meg, even a gig, it's pretty simple to restore that snapshot, especially if the open source cluster and the object storage cluster are in the same location, right? So even in the same region, it should be pretty quick. But imagine now you have a snapshot which is 1 terabyte or even couple of terabytes. So it's probably impractical to restore that entire 10 terabyte or even a gigabyte back onto the cluster, because you have to think about a couple of things. First thing is, do you have enough network bandwidth to copy that snapshot into your production or semi-production cluster? That's one. Second thing is the data required to put this temporary snapshot into the cluster. You have to kind of think about that. Well, now should I add additional volume? Then how do you remove it, configuring, and so on. So having a snapshot searchable, the way it differs is rather than restoring the entire 10 gigabyte, 1 terabyte, it'll first query the snapshot in the object storage bucket. And then based on the query, it will retrieve the results which are only part of that query. So say the result only is like 500 megs. It's not going to download the entire terabyte worth of data. It's only going to download the required amount. And then as the old data gets unused, it'll get removed off from the cache, and then it'll make room for new data. So this way, you can keep the snapshots more efficiently, where the unused data will be on low cost object store, and the queryable data, which is the most important one, will be on the open source cluster hardware with the fast disks and memory. Um, Actually, configuring a searchable snapshot is not that different from a normal snapshot. So you would use the same post snapshot command, object storage repository, and the snapshot name and the repository and the restore command. But the only difference is you have to set the storage type. So by default, the storage type is set to local. So it will copy the entire snapshot locally, and then it will try to run the queries. But if you set the storage type to remote snapshot, it'll actually try to query it while the data is still in the cluster, and then it'll cache the required data onto the open source cluster and not the entire thing. So this is especially useful if you, maybe for smaller amounts of data, you might not see that big of a difference. But if it's large amounts, and I'll talk about this a bit later, if you, for instance, have, so it's a balance between cost and time it takes for you to query the data versus the cost and time it takes you to transfer and download the data. So if you have a 10 terabyte index snapshot, maybe it's cheaper to take the additional time to query the result. Maybe it'll take 2 to 3 minutes longer, but then the result will be maybe 500 megs, which is much smaller. But if you have only a small amount of data, say 1 gig, maybe it's easier to restore and then do the querying. So it all depends on the size of your data and the geographic nature of where it's stored and how you are doing your operations. So I'm not saying one is better than the other. It depends on which use case suits the best for you. While we do these various snapshots, backups, and searching for them, generally, if there are one or two applications in your arsenal and you're managing them, it's not that, I guess, cumbersome or difficult to manage each of the um, different logs and the metrics and so on. So generally, if you have a couple of indexes, you can probably write a cron job or maybe like some sort of an automation to roll over and create the snapshot and be able to delete all indices. Like I've done that. Like I've used just simple scripts to manage the entire life cycle, right? But I soon ran into issues where if everything is going fine, it's going fine, but often things don't go fine. So where it's very difficult to keep track of the transitions between each. So after the snapshot is taken, you have to then query the API to make sure, okay, now I can do the next operation. And it's also difficult to debug if a state or if if process fails, you and if it's especially transient issue, say an API call failed abruptly, but on the next run it will run fine. So these are very difficult to debug and sometimes not that straightforward when you're dealing with different scripts. So if you have lots of applications and lots of logs, metrics, all this coming in, the better way to manage their life cycle is using the index state management. And it's just a fancy terminology for something like which you want to automate some tasks in the cluster, right? So in order to automate that, you can set up a bunch of policies, and based on those policies, you can have different operations be run on the OpenSearch cluster. So based on the backup snapshots, all that we talked about, let's say as an engineer, you have different types of data, but also different tiers of data. Let's say, and these are arbitrary, by the way, the tiers, so you could literally name them anything. But in this example, imagine data less than 4 weeks old. You would probably want that it's probably application is accessing like for your front-end facing application. Your customers might be accessing it when they search on the website. So these you generally want to be very fast. You don't want it to lag. You don't want to use slow disks, slow networking. So probably you would want to use something like NVMe drives to store the OpenSearch data. And then as the weeks go by, maybe the ETL teams and analytics team now they need to run their month end or quarter end um, scripts, ETL scripts to actually make sense of this data. So at that time, maybe you will siphon off and tier this data to another cluster, open source cluster, where maybe it's not being used as much. So maybe you'll name that ETL cluster. And you probably don't need fast networking or even as fast drives as NVMe drives. So maybe on that you'll put SSD drives or maybe even the spindle drives and have it generally if these jobs run off hours, let's say in the night or early hours in the morning, they probably don't need the fastest drives or the fastest networking. So I hope you got the idea here where like based on what type of data, where it's stored, how often you access it, you can pick and choose the type of hardware. It's not like everything needs to be SAN, everything needs to be NVMe. It's not like that. It's completely flexible. Even the only commonality here is the software. So your APIs stay the same, your installation methods stay the same, everything stays the same. It's the capacity available to those is what we are changing here. Um, and the frozen tier, so think of that as you have banks, you have financial institutions, medical. They have requirements where PCI, SOC, where just backing up or storing the data is not enough. So what they expect is not only to the data to be stored, but they expect the data to be in a searchable fashion. Like it doesn't necessarily have to be fast searchable, but they don't want you to from an archive restore it, search for it, and all that. They don't want like they generally prefer it to be in a searchable way, and then after the audit time, say 12 months, you can then delete it or whatever, right? So now you have to think about well, this is old storage, old data, which almost n- never is going to be used, but it still has to be in a searchable way. So how are we gonna like balance that, right? So we'll go through a small exercise. I'll show you how we can architect this, and then you can probably find your own ways and different ways where you can do this, right? So let's go through a small workflow. I have a brand new data which I would like to come into my hot tier. So the hot tier is the default tier where all the new data comes in. And then after 14 days, I would like this data to be rolled over and then moved into a warm tier, where in the warm tier, I probably don't want it to be writable because maybe I want only ETL and analytics jobs to use it and read it and not actually make any changes. So I would want to move that to a warm read-only tier. And then after 30 days, I would probably want to make a snapshot of it. So I just don't want to delete it because, again, for the compliance reasons, maybe I need to keep it for a couple of months and then I can delete it. So I would want to keep the snapshot around, but then I don't want to keep warm this data in the warm tier because then that is useful data on the cluster being used. So we don't want that. So after a snapshot is taken, um, the index 60 days old, then we want to delete that index from the delete tier. and then ultimately we'll delete the index as well. So let me show you briefly what the policy will look like. I concatenated some of these things and I cut out some stuff just to for the main thing, but you should get the idea still. So initially, when the new data comes in the hot tier, um, I set the minimum index age to 14 days. So what this essentially does is after 14 days, it's going to roll over to new index and then is going to transition this one to the warm tier. And again, these names are completely arbitrary. I just happen to use them in this example, but you can name it anything. But just make sure you're consistent though with the names and so on. So after 14 days, it'll be rolled over. And then once it's in the warm tier, we made it, we wrote an action so that it's only read only because we don't want it to write any new data. So the action we chose was read only. And then after 30 days in this stage, we want to move it to the object storage stage. So we have a condition in the transition. So after the index is 30 days old, we'll then transition from the warm to the object storage tier. And it's a little bit small here, but I'll try to read it. So once the object storage tier, it's in there, we have an action and a transition. So the action is going to take a snapshot of it with the repository we created when we registered it with OpenSearch. So that's the same name. Make sure that's consistent. And then the snapshot, I just left it blank, but you can name it any ID you want. But in this case, it'll automatically choose one. And then after that, I have it transitioned to the a delete state. And the condition is after, sorry, it's being cut off, but after 60 days, it will then transition uh, to the delete. So once it's in the delete tier, it's only going to delete the snapshot or the index from the OpenSearch cluster. So this is actually now going to delete it from the object storage cluster. And I'll tell you how to do that in a second. So this essentially clears out the space that original index was using, and now it'll make space for new indices on the open source cluster. So new data can be added in. Now, what do you do with the older snapshots, which are in the in the in in the bucket in the object storage bucket? So those old snapshots, you can either manually delete them using CLI or the UI, or even the object storage similar to ISM, it has ILM, integrated lifecycle management. So what that essentially does is if you have multiple object storage clusters in in the same location or multiple location or a different bucket, you can have a lifecycle management policy which says, okay, after a snapshot is more than 30 days old, move it to maybe Glacier or some other object storage where the disks and the hardware are not the most fastest or efficient, right? Like when you're just keeping backup of a snapshot at this point and probably mostly for auditing purposes, right? So um, so those you would need to manage it a different way to delete and take make sure it doesn't get like out of control. Um, and one more thing I wanted to mention was when you talk about these balancing between the different types of restore mechanisms. So you want to restore either full restore or you want to do a searchable snapshot restore. Like I mentioned, you have to not only pay attention to not just the amount of data, but also where these devices and data are. If they're located in geographically dispersed locations, you would probably want to maybe do a searchable snapshot so that it doesn't take that time to restore all the way from one location to the other. So not only does it take time and bandwidth, also it something you want to query quick, but then it's going to take a day or two just to restore, and then to to query it, it might take 2 minutes, right? So by in this case, I would probably, if the data is large and the distance is big between the data sets and what I'm querying, I'll probably make sure that I'll do like a searchable snapshot, and then the initial query is going to take long, because that's just inevitable because of the nature of it, right? Because these are two separate clusters, and if and snapshots are generally not stored in the same location as where the data is, which they shouldn't be. So when there are there's geographic distance involved, you have to account for the time it takes to query as well. So, but sometimes if the querying is slow, but the data transfer is going to be longer, then querying it makes sense. But if the data transfer is going to be quick within 5-10 minutes, then and maybe you're doing lots of queries on it, then maybe it's best to restore it the old school way and then search for it. Another way to do that is you don't even have to restore the snapshot onto like a production cluster. A lot of times I'll just have a test cluster, which I use to test snapshots up and running. And so I'll restore to that, even though it's large amount of data, maybe it'll do it during off hours. And then I'll have that data for a week to test it and so on. So those are the different ways like I've used and managed the different sets of data and so on. And you can probably see a theme with all of this, right? So um, it's not just having an external storage; it also needs to be fast because we're not just using this for backups, right? So if it's just for a backup, it's fine. It can take its own time, and then we will restore it whenever we need it in case of an emergency and so on. But when you make the storage queryable, searchable, it needs to be performant, and you can't have like an NFS or NAS. Like those will drag down the performance so much that it wouldn't even make sense to use that as a queryable mechanism. And I forgot to mention one more thing. Um, as we talk about query and scale, scaling NAS and SAN, sometimes even if you wanted to, you probably could not get it to the scale where some of the um, requirements are need to, like with ML or AI data. Like you'll probably need a lot more than a couple of petabytes to store it. And as you get it to that scale, an object store, you can easily either add additional servers to grow that existing pool, or in S3, you can add another location. And even if you want to expand the pool, you can keep one pool in one location, add another pool, and then you can connect these two, right? So you don't have to go from the get-go on lot of space, a lot of disks, a lot of hardware, and then you don't know when you're going to use it. So with this way, you can plan and you can, based on your needs, if you require more data, you can add more pools and more disks. If you feel like, okay, this, I need to scale down a little bit, this application hasn't been using as much, you can then scale down the pools and the amount of disks you have, and then you can configure it that way. So it's flexible when it comes to, so um sometimes, yeah, that's why it's beneficial to use object storage on-prem and then use it with open source, so that you get the best performance. And thank you for taking the time to listen to the talk. And yeah, if you'd like to reach out to me, yeah, that's all.